Today we will continue our lesson of how to simplify radicals. In this lesson, we learn how can we simplify the radicals by multiplying and by dividing. Now, here, when a radical is in a denominator is not a perfect square. As I told you before, as you remembered before, when I told you, like, if you have a square root of 7 over 5, this is a simplified one. But if you have 7 over square root of 5, this is not the simplified one. Today now I will know how can we make this not simplified one to a simplified one. So I want to know how can we convert this one where the denominator or the square root is in the denominator. How can we make it as a simplified one? Here they told me you have to rationalize the denominator to remove the radical. So what we have to do here, remember the step. I called it rationalize the denominator. Rationalize the denominator. What does it mean by rationalize the denominator? That's mean to remove this radical. So I want now to make some steps to remove this radical sign. By a way, we called it rationalize the denominator. Rationalize the denominator. What are the steps? The first step, you have to multiply the numerator and the denominator by the same radical expression. That's mean here I have 7 over square root of 5. I look at the denominator. What's the denominator here? It's square root of 5. I want to remove it. I will multiply here by square root of 5 down in the denominator. And since I multiply the denominator by square root of 5, I will multiply the numerator also by square root of 5. Why? Because you know that if you multiply square root of 5 by square root of 5, you get 5. Or you can say that square root of 5 times square root of 5 is a square root of 5 squared, or square root of 25. And up 7 multiplied by square root of 5, it will be 7 square root of 5. Then I will say now 7 square root of 5 over square root of 25 is 5. So this will be now the final answer. 7 square root of 5 over 5. This way now, look here now, look at the denominator, there's no square root. So I convert it to, by using the way, this way we called it rationalize the denominator. Rationalize the denominator, that's mean I will want to remove the square root from the denominator. By multiplying by the denominator, here I have square root of 5, I'll multiply by square root of 5 in the denominator, and then I'll multiply square root of 5 in the numerator to get this final answer. Let's now have another example to understand this lesson, or this step here. Now, but before that, we know that if you have a square root of 5 or a square root of 3 times square root of 3, that's mean we have we can write them in one square root, which is square root of 9, which is equal to 3. Or can say that square root of 3 times square root of 3, it's like square root of 3 squared, and the squared cancel the square root. So also we can, it's equal, we say it's equals 3. Now, let's have this problem here, problem 6, to learn how can we rationalize the numerators. You will understand more and more. Let's do now A. Square root of 3 over square root of 7. Now, the first step, I will look at the denominator. Since now the denominator have a square root, so I want now to use the way we call it rationalize the denominator. Now, what is the denominator here?
7.
Square root of 7.
7.
Square root of 7. So I multiply by square root of 7 here to remove it. And since I multiply the denominator by square root of 7, I will multiply the numerator by square root of 7. Done? This is the first step. Then after that, let's now multiply the numerator and the denominator. Now let's multiply. Here we have the square root of 3 times square root of 7. So we multiply them by each other. So they are 3 times 7, 21. And down, square root of 7 times square root of 7. As we said, it is square root of 7 squared. And I mean, I have square root of 7 2 times. And they cancel each other. So we can say that they are 7. And up, we have a square root of 21. So if you look at the final answer here, there is no square root in the denominator. So yes, this is correct. This is the simplified one.
Teacher?
Yes.
Teacher, when you use this method in making the square root of 3, can I use it in only numbers, or I have to use it in denominators?
I didn't understand your question.
Means, teacher, here the fraction, we make this method to rationalize the denominator.
Yes.
Can I use this method by any number without any number, not a fraction?
By any number, not after. Give me an example.
Like, teacher, you made square root of 3. What is the square root of 3? You multiply it by 3, and then you make the square root of 9 equal 3. So this is correct to use this method?
Just if you have example like square root of 3 over what?
Yes. 3 only. I cannot use this method.
Square root of 3 over 3?
Yes.
This is no. Yes, because look at here. Here in the denominator, you don't have a square root. So this is the simplified one. This is simplified. I don't need to simplify it. Only if I have a square root in the denominator, like this as an example, I have to simplify it. Did you remember here at the beginning of the lesson? Did you remember this one here when I told you that this is not simplified one? Why? Because we have a square root of 7 on the denominator, as you see here. So since this is not simplified, I want to convert it. How? By using rationalize the denominator. After I used with the way of rationalize the denominator, I convert to a one which is simplified. How? Here we have square root of 2 over 4. That means I have only the square root in the numerator, which is correct. So the square root must be existed on the numerator only. If it is in the denominator, I have to make an action. I have to simplify it.
Okay.
Okay?
Okay.
Now, let's do B now. In B here, we have a square root of 7 over square root of 8n. Now, what is the denominator here?
Square root of
8n.
Square root of 8n. Okay. But now, so I have to multiply now by square root of 8n. Oh, and up here we have square root of 8n. Then,
I cannot find. Okay, yes.
now then, here we have two square roots, as you see, here one, and here you have the other one. We can combine them in 7 times 8, 56, n over square root of 8n times square root of 8n. What's the answer? Yalla, quickly.
64n squared. 64n or
8n squared.
Or you can say 8n. Let's quickly, shortly. Square root of 8n times square root of 8n. As I told you, square root of 4 times square root of 4, it means square root of 4 squared. They cancel each other, so it's 4. So if you see that square root of 4 times square root of 4, they are this multiply, and I mean that if you have a square root of 4 multiplied by square root of 4 times square root of 4, that means they are multiplied by each. So take this answer only. Take this 4 only. So tell me that the answer is 4. So here take only 8n.
Okay.
Okay, now let's continue. Now here we have, as you see, we have, but I didn't stop here. Do you know why? Look at the numerator. The number under the numerator is not a prime number or a composition or a product of two prime numbers. It's 56. Look at 56. Is it a prime number?
No. Yes.
Yes or no?
No, it's not a prime number.
It's not a prime number. Okay. If you now factorize it, give me two numbers. If you multiply them, you get 56.
7 and 8.
7 and 8. Are 7 and 8 are a prime number?
No.
Also no. Because of that, I cannot stop here. So I will repeat. I will ask myself, is 56 a prime number? No. Okay, let's factorize it. After we factorize it, we have 7 and 8. Are 7 and are 8 is a prime number? No. So I have to simplify the square root of 56 by the ways that we learned in the last week. Now, how? We have 8, which is 2 times 4. Now, so we have, look at the three numbers that I stopped with them, 7, 2, and 4. Which one from these numbers are a perfect square?
4.
4. So let's write them now as square root of 7 sorry. So let's write them as square root of 7 times square root of 2 times square root of 4. And so square root of 56, I wrote it as square root of 7 times square root of 2 times square root of 4 times square root of n over 8n. Then let's now simplify. What is the square root of 7? Keep it as it is. There is no
Nothing.
square root of, yeah. Square root of 2,
Nothing.
because 7 and 2 are prime numbers, so there's no square root of them. Keep them as it is. Now, what is the square root of 4?
2.
It is 2. Then, square root of n, I cannot simplify it. So I will say I have 2, and let's combine now 7 and 2 and n in one square root. 7 times 2, 14 times n,
14n.
14n over 8n. Now, I want the simplified one. Can I stop here now? Look at the numbers, 8 and 2.
No.
Are they simplified, 8 and 2? No.
No.
If you divide down by, or up by 2, you get 1. If you divide down by 2, you get 4. So because of that, I will say now that the final answer is square root of 14n over 4n. This will be now the final answer. Is it clear now?
Yes. Yes, teacher.
So I need to simplify it. The first way, I started with rationalize the number. Then I have a numbers under the square root, but it's not a composite one. I need now to simplify it using multiplying. Then after that, after I finished how to simplify the radicals, and if you look at the radicals here, it is a simplified one. But if I look at the numbers, which is not radical, then it's not the simplified one. I will simplify it. Let's have now, before that, do you have any question here?
No, teacher.
No, teacher.
Okay. What is a simplified form of each radical expression? Let's start with A now. Square root of 2 over square root of 3. Now, what is this, the radical here? Or what is the denominator, sorry?
Square root of
Square root of
3.
And up, I will multiply by
2.
square root of 3. No, the same number. Up and down. Then, square root of 3 times square root of 3. After multiplying, what I will get?
9.
Yes, square root of 9. Okay. And up, square root of 2 times square root of 3.
6.
6.
Square root of 6. Okay, then it's square root of 6 over 3. Now, look at square root of 6. Can I stop here?
No.
Why no?
No, miss.
Yes, teacher. Yes.
Teacher, okay, what's about the 9? Like,
Square root of 9 is 3.
we only write the square root of the number that give us the answer.
What did you mean?
I mean, like, the 3 times 3, 9. We only write down, like, the final answer, the number who, the number who give us the answer.
The number will give us the answer.
Like 3 times 3 give us 9. And then we write 3, not 9.
No, here you have square root of 9. Don't forget it.
Oh, okay.
Okay? Now look at 6. I ask you if I stop here or no. I told you when I can stop if I have a prime number only, or a composite, or a product of 2 prime numbers. Let's factorize 6. Give me 2 numbers. If you multiply them, you get 6.
2 and 3.
2 and
2
3.
and 3.
Now
2
look
and
at 2
3.
and 3. Are 2 and 3 are a prime numbers?
Yes.
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 Since they are a prime, the 2 numbers. Oh, since the 6 is a product of 2 prime numbers, so I have to stop here. Is it clear?
Yes, miss.
So this is the final answer. I will ask myself, is a 6 is a prime factor? No. Okay. Let's factorize 6. After we factorize it, we get 2 and 3. Are 2 and 3 is a factor is a prime or are prime numbers?
Yes, teacher.
Yes. Since 2 and 3 are prime numbers, so I cannot factorize the numerator or the square root.
Teacher,
Yes.
Jenna is saying that her net is so bad and she got out so she can reconnect, and she wanted to hear you. So she got out to see if the sound will be better.
Okay. Yeah, now let's do B. In B here, we have square root of 5 over square root of 18m. Now, let's have another way. Now, look at square root of 18m. Okay, look at number 18. Is 18 a composite as a prime number?
No, teacher.
No. So, type 18 is not a prime number. Let's now factorize it. Give me 2 numbers. If you multiply them, you get 18.
9
3 and
and
6.
2.
9 and 2. Now, 9. Now, which one is a perfect square?
9.
9. So I can write now square root of 18m as 9 times 2 times m. Okay? I can write 18 as 9 times 2. Then after that, now, let's simplify it. Keep up as it is. Look down here. We have square root of 9 times square root of 2 times square root of m. Then let's now rewrite them as, what is the square root of 9?
3.
3. Square root of 2, keep it as it is. And the square root of m, nothing. So keep it as it is and combine them with 2. So what did I get here now? I have square root of 5 over 3 times square root of 2m. Until now, is it clear?
Yes, miss.
Yes, teacher.
Okay, now look at the denominator. Did I have a square root under the denominator?
Yes.
Yes.
Yes. So let's now continue here now. Here we have square root of 5 over 3 times square root of 2m. Now, where's the denominator? Where's the square root in the denominator? Is it a 3 or a square root of 2m?
Square root of 2m.
Exactly.
Square root of 2m.
So I will multiply down by square root of 2m only, and in the numerator, I have to multiply by square root of 2m. I multiply only by the numbers or by the radical number. Then after that, look at the denominator now. What did you have?
Teacher, it will be 2m times by 3 equals 6m.
Exactly. It is 3 times square root of 2m squared. And since they cancel each other, so I will say it's 3 times 2m, so which is 6m. Now let's come back to the numerator now. What did we have in the numerator here? We have a square root of 5 times 2m. Is it right?
Yes.
5
Yes.
times 2m. Let's combine them. We get 10m.
Yes.
10m.
10m.
So I have now square root of 10m. Now, can I stop off square root of 10?
Yes, because
Yes.
it's a prime number.
Yes, it is a composite of prime number. Thank you. If you factorize 10, you get 5 and 2, and both of them are prime numbers, so I have to stop here. This is now a way how can we simplify this radical expression. Is it correct?
Yes.
Is it clear, sorry?
Yes.
Yes, miss.
Yes, teacher. Thank
Now let's do C. And C here, we have square root of 7s over 3. For this one here now, what we have to do? I want you now for the first step to distribute the square root onto the numerator and the denominator. So the first way I have to distribute the square root. Then, what is the number, or what is the square root in the denominator?
3.
Square root of 3. So since I multiply down by square root of 3, I will multiply up by square root of 3. Then here we have 7 times 3 times s. Let's combine them now in one square root. 7 times 3 is 21s over square root of 3 times square root of 3.
3.
We cancel each other, so I get 3.
3.
Exactly. Now, can I stop at square root of 21?
Yes, because it is a pair of two composite numbers.
Thank you so much.
Pair.
Yes, it is 7 and 3. They are a pair of two prime numbers, so I have to stop here. So the final answer is square root of 21s over 3.
So teacher, we stopped when we get a prime number.
Yes, prime or a product of two prime numbers.
Okay.
Okay, now let's choose now 36, 37 is a division. 40, we have 40. This is how to simplify by dividing, and 44. So let's solve 40 and 44. 40 is related to problem number 5, simplifying by division, and 44 is a way for a radicand. Let's solve first 44 for our likes, which is related to our lesson. 3 square root of 6 over square root of 50. Start it here. Now, before using simplifying the radicals, look at number square root of 15. Is it a prime number?
Yes.
No.
And
Is it
teacher,
a
it doesn't
composite
have
of
one.
prime number or a product
No.
of 15?
Yes, yes.
Think about it.
Yes,
It's 5
yes,
times
15.
3. And 5 and
Yes.
3 are a composite, a prime numbers. So yes. So now what is the number in the denominator here? Which have a square root?
Teacher,
15.
it's square root of
It's
15
a
only.
composite of two prime numbers.
Ah, okay, there's no 3. Thank you. So I have a square root of 15 only. So what I have to do here? Rationalize the denominator. Is it right?
Yes.
Fine.
Yes.
Square root of 15. I have to multiply by square root of 15 in the denominator and square root on the 15 on the numerator. Then square root of 15 times square root of 15 is 15. And then here, what did we have? We have a 3 without square root. And with the square root, what did I have? I have a square root of 6 and square root of 15. Let's multiply them by each other. 6
90.
times 15 is 90, yes. This is how here I multiplied 6 times 15, which I get 90. Then look at 90. After that, now I remove the square root from the denominator by simplifying, by rationalize the denominator. But okay, this is the simplified in the denominator. But in the numerator, this is not the simplified one, because 90 is not a prime number. So let's now factorize the 90 by using the multiplying way. Now let's use 90. 90 is a product of which two numbers?
Teacher, 30 and 3.
10 and 9.
Yes.
Yes. 10 and 3.
So I write it as a 3, keep it as it is, and under the square root, I have to multiply 9 and 10 over 15. So it's a 3 square root of 9 times square root of 10 over 15. So it's a 3 times 3, which is square root of 9, times square root of 10 over 15. Now, after this step, I simplify the denominator, then I simplify the numerator. Now look at 3 and 15. Can I simplify them? Can I?
Yes, teacher, but
Yes.
teacher, you must.
Here,
If I
yes,
make-
divide by 3, we get 5. Since I only simplified the numbers, not the number with a radical, number with number. So what I get now? I get, let's here write the final answer here. I get 3 square root of 10 over 5. Is it clear? I know that you have many ideas in this lesson.
Yes, teacher. طب if I made it 9 times by square root of 10 over 15, it will not be the simplified form?
No, because you can simplify them. If you get it as 9, like, wait.
Yes, I must simplify it to divide by 3, divide by 3. Okay.
We have 9 square root of 10 over 15. You can say divide by 9 is 3, divide by 9 is 5. So you get 3 square root of 10 over 5.
Okay.
Is it clear, miss? Okay. Now, since the period is finished, I have to stop here now. So by now we finished our lesson. Please do the homework. Try to solve more examples related to this or more problems related to this lesson. If you have any problem, kindly tell me.
Okay, teacher. Goodbye. Have a nice day.
Thank you so much. Have a nice day.
Okay, miss. Thank you so much, miss. Have a nice day.